In this video, we're just going to go through a couple problems that have unique solutions, so we know what to do when we see them and we understand what we're talking about. So for this first one, it's already set up in elimination, like it looks nice for elimination, so I'm going to go with that because I notice my x's right here, 3x, negative 6x, that seems pretty simple. I'm just going to multiply this top equation by 2. And that will give me, what, 6x minus 8y equals 24. And my bottom equation would be negative 6x plus 8y equals negative 24. So now when I add those together, I'm going to get 0 plus 0 equals 0, or aka 0 equals 0. Now, it's not, don't be focusing on the 0 equals 0. If you had gotten 4 equals 4 or any true statement, that is the same scenario. And what we're seeing here is that any solution works. So we're going to be careful though. In this class, we're not going to actually just say any solution or all real numbers or infinity, which you may have done in some previous classes. We're going to be a little more specific. Okay, because the problems, for example, may say state your answer in terms of x. If the problem asks for it in terms of x, we're going to take either equation. In this case, it doesn't matter. But we're going to write down the equation, and we're going to go ahead and solve it for y. The reason why is, think of substitution method. When you solve for y and you substitute it in, the y goes away. So what we're going to do here is solve for y because we want our answer to have x's in it. So I'm going to go ahead and solve for y. So I'm going to subtract the 3x over, divide by negative 4. And if you chose to write it this way, that would be fine. You could also write it as what? 12 divided by negative 4, which would make negative 3. Well, I should have y equals. There we go. So that'd be negative 3. And then a negative 3 divided by negative 4 would make a positive 3/4 x. So either one would be fine. WebAssign and my tests, I don't care which way you write it. They're both fine. But here's how you write your answer. It's still an ordered pair, right? It's still the concept of a system of equations. So what we're going to say here is normally our answer is an x value and then a y value. The problem wants it in terms of x. So I can have x's, I'm not allowed to have y's. So therefore my answer is any x value, you pick it, any x value will work. This problem has infinitely many solutions. Pick an x. And then what would your y value be? You don't get to pick that at random, right? It has to be on the line. So I'm going to use my equation that I just came up with, and either one would be fine. But I'm using the equation I just came up with to write my y value. And there you go. So now you can see you pick any x and then you fill it into this equation and you get its y value. So this does have infinitely many solutions because you can have any number for x, but it has a very specific y. So now if the problem instead asked for it in terms of y, what would that look like? How does that change the process? Well, it kind of doesn't change too much. We would take the same equation, 3x minus 4y equals 12, but now, instead of, if it wants y's, that means I need to get rid of x's, right? Which means, therefore, instead of solving for y, I'm going to solve for x. So therefore, I'm going to have 3x equals 12 plus 4y. I'm going to divide everything by 3, which will give me x equals 4 plus 4/3 y. And now my answer, which is normally x and a y value, instead, everywhere I have an x, I'm going to replace it with this stuff. So I'm going to have 4 plus 4/3 y, comma, y. So now you can see each of my answers is in terms of y. So if you see that notation, that's all it's saying. And later on, when we get to some calculator techniques, I'll show you some ways to kind of speed this up so you're not doing so much by hand. But it's always good to do the first few by hand. Okay, one more thing before we move on. What does this system look like graphically? Well, what this scenario means, when you have a number equaling a number, like 4 equals 4 or 0 equals 0, if you were to graph this line, whatever it may be, let's assume it looks like this, the other line is directly on top of it. And if you want to verify that, graph them. You can use your calculator, you can do it by hand, whatever you want. But the idea here is, why do we have infinitely many solutions? Well, it's because there are infinitely many points that you could pick that overlap. It doesn't matter. Pick any x value, they're always the same because they're the same line. All right, so now on to the next problem. This problem, very similar. You'll notice elimination technique looks good for this, and it also looks great to multiply by 2, right? All right, so I'm going to go down here. So let's see, this would give us 6x minus 8y equals 24. And the bottom equation would stay negative 6x plus 8y equals negative 14. This is all great. The only issue here is we're getting 0 plus 0 equals 10. Okay, so therefore this is saying 0 equals 10. How is this different than the previous problem? Well, the previous problem was a true statement, 4 equals 4, 0 equals 0. This one is 0 equals 10. That's false. So what does it mean that it's false? Well, if you were to graph this, I'm just going to freehand it. If you were to graph this, you would see one line and another line that are parallel, which means they have no solutions. They have no points of intersection. So therefore, this one we would say no solutions. And that's as easy as that one goes, right? No special notation, nothing special on that one. All right, so that takes care of the special solutions, special problems. So we'll see you in the next video.